And welcome to the latest video following the restoration of our 2-foot gauge Fowler Works number 16341 ex Tully Sugar Mills number 5. First thing in this video, we need to just go over the end of one of the stories that we did in the last video. The brake shaft that you can see here, the brake cylinder's on this side and the shaft goes across. This is looking down from the top of the loco toward the back. The little bracket that you remember from last video, where we rebushed and we remade it all, where we left a couple of thou tolerance on the brass. But in actual fact, when we found that we tightened them up across the frames, it went tight a little bit on the shaft. It actually still rotated, but it just wasn't quite enough. So we took those brackets off again. Neil skimmed out the bore a little bit to allow more like 5 thou each side. And then you can see here is also machined an oil pathway in there, in a ring all the way round, grease pathway in this instance. And he's just using the Dremel to clear a nice clear pathway through for the grease to be able to get in and into that slot, whereupon it'll be able to get right round that clearance and the shaft won't go tight. So that tied it up, moving on to the main story. The balance beam for the suspension, which fastens to the spring hangers and ultimately the springs, needed a lot of work to rebush it and to remachine it to get it ready. You may remember from very early video, this is how it came off the engine, and it had a cast iron bearing in it that had shattered. Ultimately, all the load of the engine goes on that bearing, and therefore it just was too brittle and it had life expired. So we cleaned it all up. This is it after bead blasting and cleaning, and we machined through for new pins for the ends, for the spring hangers. The new pins sitting in there made to 29.5mm, which we decided to open up to, which was a nice size that we could open up to so that we can make all the pins the same and not oval. And then we used the clocking up mechanism to find the centre. We machined it out and pressed in a machined ring in there so that we got the right size meat. And then we bought off the shelf roller bearing inners. So they're the hardened steel insides off a roller bearing that you can buy commercially. They only came in certain sizes, hence the need for the ring that we pressed into the actual suspension beam so that we could then bore it out, as you see here, to fit the commercially available hardened steel ring. We decided that was a really nice way of doing it. And a relatively inexpensive way of doing it because we could just buy the mass-produced roller bearing rings off the shelf. So the two rings, we put 2 in. As you can see, that meant that there's a groove between the two, which we thought would also help to get the grease through into the areas that it needs to. So that's what's going on there. They've been pressed in. Moving on to the pins that go into that hole. These are the original pins, and you can see they've been eccentrically worn. Obviously, all the weight is unidirectional from the locomotive, pressing down on the pins. So they tend to wear, as you can see here, into a groove. The pin itself is static in the frames, but the point at which it rotates is worn quite badly. We took the decision in this particular instance, particularly because they're the main load-bearing area for the whole weight of the engine, that we'd make new pins. So as you can see, this is Neil going through the process of making those pins. That's the first stage, to machine the shaft up. There's an area there that fits in the frames, the area that then fits the pivot bar, and then the other area that fits on the bracket on the inside of the frames that you'll see when we take a closer look at the frames later. So this is more of the machining process. When you look at the actual pin, it's got a hole in the top which is threaded, and the grease pot will go into there to fill with grease and feed through. This is Neil showing it fitting into the balance beam that you can see with the 2 roller bearing inners in there. It fits really nicely. We just left a couple of thou tolerance there, but not a lot at all because it doesn't spin or get hot, and there's not a great deal of distance for twist that would allow it to get locked. The flat is so that we can put a piece of metal on the frames to stop it twisting, and inside here you can now see there's a groove for the grease to get into the middle where the joint between those 2 roller bearing inners were, that allow us to feed straight down that threaded hole. I'll put the grease pot in the end. This is the original grease pot off the engine, cleaned up and restored, so that goes in there, and then that pin with the ring on the end is ready to go back in the engine. We'll harden it first. So in actual fact, the next time you see it, when it goes in the engine, it'll be a black colour because it'll have been case hardened. Next stage was to open out and clear out the holes in the frame. So this is Dave clearing away the paint. They actually had a hardened steel bearing in there, and that's what we're making here on the lathe. Again, we made new ones because this area is where the entire load of the engine goes. They're tapered on the outside surface and pressed into the frame, parallel obviously on the inside bore for the pin. That's the one now looking from the inside of the frame's already in place, and this is the bracket that will hold the one on the other side, on the end of the pin. We lifted, and this is me lifting the balance beam up into place. Neil pokes the pin through from the outside and then pushes on the bearing that is made, the second one of the two bearings, which again, as I say, is tapered the opposite way. And then he had a couple of collars which he can put over the pin to be able to push it. And if you watch closely as he hits it, you'll see that the bearing is pushed into that hanger bracket. There we go, just knock it in, just up, just till it goes tight. And then the collar itself will go on there afterwards and be pinned through. You can see the pin itself's now black, as I mentioned earlier, because it's been hardened. And it just takes a couple of minutes just to keep pushing that bearing in to get it all to lock up tight before ultimately one of those two rings that Neil's using to hit it will go back on the shaft permanently with the split pin through it. Yep. And there's the shaft swinging smoothly with side float in it, but no actual slop in the pin. Exactly the same process for the other side. This is Neil just knocking in the other tapered bearing, and then we'll be able to see that side finished too.
Sorry?
Just wiggle it up and down again. Well, you are doing anyway.
Oh, yeah.
The ends of the balance beam fastened with the pins that we talked about earlier that we made new into the spring hangers, the upright vertical sections. Now, as you can see on the original drawings, it's just one straight rod going up as a spring hanger. In the course of its working life, Tully Sugar Mill had obviously modified it with this extra bracket in there that you can see that allowed more flexibility in the upright hanger, which presumably allowed the springs a little bit more movement so that they didn't ever lock up or go tight. Perhaps it helped it ride better. We've decided to keep that because it was obviously a modification that they also decided to keep in practice. This is one of those extra links being cleaned up in the milling machine. They were a bit rough because I think they were fabricated at Tully Sugar Mill by the fitters there, so we're just skimming it all up to make it look nicer. The ends were then all bored out, as I mentioned right at the beginning, to 29.5. That was the smallest diameter that we could get away with, where we could open all the oval holes out to exactly the same diameter and make a brand new set of pins. Again, there were some of the pins that we could have reused, but this is all the fundamental load bearing of the engine, and we wanted it to be viable and usable as well. So this is one of the areas where we decided that it was worthwhile making brand new parts rather than restoring the old. The brackets on the frames were all bored out and then reamed out to 29.5 to allow it all to go together with the new pins. This is that process happening. Dave and Ian on the big drill there, we went through the whole lot and machined everything to the same. Again, there's a degree of usefulness in having everything standardized at that size, and this is looking from the outside at the new pins through in the end of the spring balance beam into the bottom of those links. So that's the whole assembly finished and back on the engine, waiting for the spring hangers and springs to go on. The next topic in this video, quite difficult to see because there's a lot of detail in the drawing, but this is the reversing lever. So that's the reversing lever shaft. Then there's the little lever that you pull to release the tongue from the quadrant. The arc that it goes through is described there. Now, if you look down here, there's the reverser reach rod, which you can see in the dotted lines here. I'll follow it with the pencil. That goes all the way forward to the lever, the vertical lever, which is, you can see the diagonal sides of it, but it's a straight vertical lever that goes down to the bracket that holds the way shaft, which is the central part that I'm describing there, through the engine to operate the reverser. Now, this is on the engine. The top cap on the bracket's quite nicely shaped with a grease hole in the centre, and the reach rod itself you can see is bent. The engine's had quite a heavy front impact at some point that bent the frames, bent the reach rod, and fractured the top cap. So Tully Sugar Mills had made that square, simple, plain one from steel, which fitted the shaft and had the bulk of the machining done, but obviously looks very crude and square. So what we did was we took all the measurements from the other one on the other side. We made a 3D CAD model of it, and that's what you see here being manipulated in the computer. And then we entered that data into the CNC milling machine, and here's the original square steel Tully Sugar Mill made bracket cap being machined to the 3D shape of the other one. So we essentially manufactured a new shape so that the both sides matched and looked original. Quite satisfied with the way it worked, and as you watch a couple of quick shots of the process happening, it's quite nice and satisfying to see it all being milled out to match the original design, whilst using the original Tully Sugar Mill modification part. Here's the two parts next to each other. You can see the original on the right and the newly made one on the left. They're pretty indistinguishable, apart from the fact that the one on the right has quite a few more dints and bumps in it from its longer life. This is the bracket itself all assembled, and the original brasses in there. We actually shaved a little off all the mating surfaces and then rebored a new diameter through there to take the remachined shaft, which you'll see later in the video. This, in fact, is that shaft, but this is removing the two lifting arms from either end. This are the lifting arms that lift the valve gear up and down in forward and reverse. We had to heat them up to knock them off. This was done a long time ago, but obviously I videoed it at the time, and now it's become relevant for the videos. You can see the shaft itself was incredibly badly pitted, but such a strong item that it didn't need any significant repair other than cosmetic, which, as you can see, we've now done here. So this is the cosmetically repaired shaft with its undercoat of black on it, and what we're doing here is we're skimming as lightly as we can the surfaces that go in that bearing that you saw us machining earlier, only those surfaces. So the diameter where we press on the lifting links and where we press on the reversing arm that you'll see next weren't touched at all, because obviously they want to remain exactly the same for the levers, but the bearing surface was machined down ever so slightly, which then fitted the machine diameter of the bearing. Now back to the reversing lever. Again, it's important that it was straight. So as you see it here, it isn't straight. This is a result of that front end impact that bent the reach rod and shattered the bearing cap. So again, we need to straighten that, otherwise the reversing lever won't sit in the right position on the quadrant for lifting up the valve gear. So this again is the same process that you've seen us use before. Heating up the rod itself until it's really malleable, and then pressing it in the 50-ton press. The process isn't shown here because we've shown you that before in previous videos, but you can see what's basically going on. It twisted a bit in the process, so it was a sort of half-hour job of heating and repressing, and then Neil here just finally tweaking it to make sure that the offset, the joggle in the lever, was the correct amount to miss the back of the tank. The dints in the lever from the whole process and for the impact from the crash were then welded in to get a nice flat finished surface that we can then grind up for a pretty lever. This is the culmination of that whole process. So that's Ian putting one of the top shells in, and then the new cap from the bracket. This is the one that we machined up from the original Tully Mill repair. Slots back down nicely. The same process on the other side with Neil popping the shell and the cap, the original cap, on. And then with all of those tightened up, there was just enough few thou clearance on each of them to allow it to be able to tighten up without going tight. And you can see after tightening it up, the shaft still rotates enough. And that's everything for this video. Thanks again for watching. There will be another one along shortly.